Okay. Spring homework number 2, graphing radical equations. So, right here, it says identify the domain and range of each. Okay, so now for starters, um, in order to find the domain and range, guys, you first have to ask yourself this. That square root is going to be 0 when? So, basically, I know if I'm just going to make a miniature XY table. For starters, I know that, if I plug in 2 into x, then we're going to get a square root of 0 on the inside. So if you plug in 2, this is going to be 2 minus 2 plus 5. Well, 2 minus 2, you guys, is 0. So square root of 0 plus 5. Square root of 0 is 0 plus 5, and that's just going to be 5. So 2 comma 5. Now let me talk to you guys about the transformation. This right here, you guys, that means your parent function is going to move right 2. And this means it's going to go up 5. So if you were to just do a sketch, right, here's the original. Here's just a Cartesian plane, a graph. And your parent function would have been right 2 and up 5. Which is essentially there. And you know the parent function would just look like that. No, sorry, not the parent function. The new transformed equation. Well, that's what we found right there, right? That was 2 comma 5. So you know the function's increasing, so to find your domain, right, it's essentially just going to be, well, how far left does the graph go? Well, it goes to 2. How far right it goes? To infinity. The range is all your y values, so when I look at this, I'm like, okay, well, when I look at how low it goes, the graph goes as low as 5. Brackets, because you see the actual point, and then it continues to go upward. So 5 to infinity. So domain, how far left does the graph go to how far right? And then range is how low does it go to how high. Don't do 3 because I told you guys that's not part of your homework. Number 2. Alright, so again, let's find the starting point. Well, let's go, I'll just do vice versa. Well, you know this goes left 2, and you know this goes down 3. So you know your graph is going to go left 2 and down 3. So it's going to start there, and you know it's from the parent function. So the parent function looks something like that, right? So that makes it a lot easier. So when we find the coordinate, right, what makes that square root be 0? Well, if you plug in -2 into there, you're going to get square root of -2 plus 2 minus 3. Square root of 0 minus 3, 0 minus 3, -3. So you know this coordinate's -2 comma -3, and that's going to help us because our domain is going to be, well, how far left it goes all the way to -2, and how far right, it goes to infinity. The range, how far left does it go? Or sorry, the range is how low it goes, -3, to how high, to infinity. And this gives you guys all of the valid x and y values for this function. So this is how you guys find your domain and range. Has to be in interval notation, okay? All right, now when we sketch the graph, right? So you want to get these perfect squares, right? In order to make a sketch. So I'm going to make my XY table. So first, well, since it's just a square root of x, to get that to be square root of 0, because that's the first perfect square we know, I'm just going to plug in 0. So square root of 0 is just 0, and 0 plus 5, you guys, is 5. So there's my first coordinate, 0 comma 5. Next coordinate, to get a perfect square of 1, all x has to be is just 1. So square root of 1, you guys, is 1. 1 plus 5 is 6. So 1 comma 6. Then to get a perfect square of 4, well, all we gotta substitute in for that x is just 4. So square root of 4 is 2. 2 plus 5 is 7. 4 comma 7. And there is your guys' sketch. Now, if you were to use your transformation for even more emphasis, isn't that just up 5, right? Parent function. If this was the parent function right here, right? It would have just gone up 5 units, which you know you've done it correctly. 6. These are all nice, you guys, because, right? Again, you guys are trying to get this, right? Well, plug in 0. Square root of 0 is 0. 0 minus 2, negative 2. Plug in 1. Square root of 1 is 1. 1 minus 2, negative 1. Substitute in, nope, no, sorry, not 2. We want a square root of 4. So substitute 4 into x, we get square root of 4, which is 2. 2 minus 2, 0. Gonna plot all these. And there's my graph. And this graph makes sense too, because isn't the transformation down 2? And, right, this would be the parent function, and from the parent function, all you would have to have done is just move it down 2 units, and it would have matched up to that. So, right, you guys can use your transformations to even give you more emphasis if your graph is matching up. Alright, 7. Okay, so that's really up 3, right? So you know this graph is essentially just going to be up 3 from your parent function. But for more precision, just make a table. Okay, for this to get a square root of 0, all x has to be 0. So square root of 0, 0, 0 plus 3, 3. Now, to get this to be a square root of 1, all you have to substitute in x is 1. So square root of 1, 1, 1 plus 3, 4. Next, and the next perfect square is 4, so substituting 4 into x. So square root of 4 is 2, 2 plus 3 is 5. Yep, and there you guys go. 8. So first perfect square we're going to go for is 0. So square root of 0. So if we put 0 into x, square root of 0, 0. 0 plus 4, 4. Next perfect square is 1. So square root of 1, 1. 1 plus 4, 5. Next perfect square is 4. So square root of 4, 2. 2 plus 4, 6. So 0 comma 4, 4 comma 6. No, 1 comma 5 and 4 comma 6. And again, you guys can use your knowledge of transformations, right? Because that's up 4. So basically, the parent function, which would have been like right around here, right? That transformation tells me your parent function just moved up 4, which seems to match up with what we graph. So again, just use your guys' knowledge of parent functions in order to make sure. Use your knowledge of transformations of parent functions in order to test to make sure you guys are doing it correctly. Alright, so we have this one, and I'm actually going to show more work on this. So remember, this is the goal. We know what the square root of 0 is. That's 0. We know what the square root of 1 is. That's 1. We know what the square root of 4 is, which is 2. So that's what we're trying to achieve here. We're trying to figure out what the what value of x would give us these perfect squares right here. So xy table. Okay, now I know in order for this to be the first perfect square of 0, I'm going to set x to be negative 2. So if you substitute x into our function, we're going to get -2, -2 plus 2, -2 square root of 0, -2 times 0, which is just 0. So -2 comma 0. This is when x is equal to -2. Now, we have to figure out, alright, the next perfect square we want is try to get that to be a 1. So, what would we substitute into x to get 1? Well, we would substitute a -1. So let's do it. -2 square root of -1 plus 2, -2 square root of 1, -2 square root of 1 is just 1, you guys. -2 times 1, -2. So -1 comma -2. Lastly, we want this to be a 4. So what value of x would you substitute into there to get a 4? A 2. So if x was equal to 2, -2 square root of 2 plus 2, -2 square root of 4. Square root of 4, you guys, is just 2. -2 times 2, -4. And your graph would look something like that. Now, if you guys knew your transformations, right, this tells you from the parent function it would have went left 2. This tells you it's a stretch, a vertical stretch, and this tells you guys it's a reflect across x-axis. So if this was truly my parent function, you would move it to the left 2, right, which would have been there. You would have reflected it across the y-axis. So I don't think this could reflect. Well, anyway, your reflection then would be something like this, right? And then since it's a stretch, that makes sense that it matches up. So you know that you did it correctly because it all matches up using your transformations. So, do a table, you guys, for precision, and then write the transformations that you guys do know should even more emphasize that your graph is correct. Oh, we're not doing that because that's like, we're not doing that one. We're not doing 12 either. All right, so here we go. Again, when you graph, you want to get these on the inside of the root, right? Okay, so well, what would give us 0? Well, if x was 4, that would give us 0. So if x was equal to 4, we'd have square root of 4 minus 4 minus 2. 4 minus 4, you guys, is 0. Square root of 0 is 0 minus 2. 0 minus 2, -2. So that's going to be 4 comma -2. Now, next, we have to try to figure out what would give us a 1, a perfect square of 1. Well, a 5 would. So if x was equal to 5, we get 5 minus 4 minus 2. 5 minus 4 is 1 minus 2. Square root of 1 is 1 minus 2. 1 minus 2, -1. 5 comma -1. And then lastly, what will give us a 4 on the inside, it would be an 8. So if x was equal to 8, substitute that into the equation. So 8 minus 4 minus 2. 8 minus 4 is 4 minus 2. Square root of 4 is 2 minus 2. 2 minus 2 is 0. So our coordinate's going to be at 8 comma 0. And this is what your graph is going to look like. And then if you want to use transformations to check your work, right? This is a down 2, and this is a right 4. So we could use this as a point of reference. So this is your parent function, and if you guys use transformations, that would help you decide, right? So if you moved it down 2, 1, 2, and then you would move it right 4. 1, 2, 3, 4. And look at that. It pretty much is pretty accurate on where we were. So again, the transformations you guys, right, it further emphasizes that you did your graph correctly. All right, 13. So let's graph it first. Again, remember, this is our goal, right? In order for us to find nice, clean points. So what value of x would make that square root a 0? A 2 would. So if you substitute 2 into the equation, we get this. 4 times square root of 0 minus 1. Square root of 0 is just 0. So 4 times 0 minus 1. 4 times 0 is 0 minus 1, negative 1. So our first coordinate is going to be 2, negative 1. Okay, now what value of x would give us a 1? That would be if x was 3. So if x was equal to 3, we get 4 square root of 3 minus 2 minus 1. 4 times square root of 1 minus 1. Square root of 1, you guys, is just 1. 4 times 1 is 4, minus 1. 4 minus 1 is 3. So that's going to give us 3, 3. Oop. Okay, now lastly, we want to try to get a perfect square of 4. So what value of x would we substitute in there to get 4? That would be a 6. So if x was equal to 6, we'd have 4 times square root of 6 minus 2 minus 1, 4 times square root of 4 minus 1, 4 times 2, because that's the square root of 4, 8 minus 1, which is 7. So 6, 7. And this is what your graph would have looked like. And our domain and range, you guys. Domain, how far left does this graph go? Well, you always use your first coordinate. So, at that coordinate, it's 2, negative 1. So, how far left? Well, 2. How far right? It goes to the right infinitely. Range, how far down to how far high? So, how low does it go? Negative 1. To how high? To infinity. Now, if you guys use your transformations, right? This is down 1. This is right 2. And this is a vertical stretch. So you know your graph is going to get skinnier from the parent function. It's going to move right 2 and it's going to move down 1. So if I drew your guys' parent function, which is that, so if I moved right 2, I would be right there. If I moved down 1, it would be right there. And then it got stretched vertically, right? So it got stretched out vertically. And that seems to be pretty decent. It seems to match up pretty decently. Okay? So again, transformations just further emphasizes that you guys did your graph correctly. Okay, 14. So what value of x would give you guys 0, 1, and 4? Well, we would get 1. So we're going to get, when x is equal to 1, negative 3/4 square root of 1 minus 1 plus 4. Negative 3/4 square root of 0 plus 4. Negative 3/4 times 0 plus 4. 0 times negative 3/4, you guys, is just 0 plus 4. So that's just going to be plus 4. So that's our first coordinate at 1, 4. Okay, now what value of x will give us 1? That would be a 2. So when x is equal to 2, we're going to get negative 3/4 square root of 2 minus 1 plus 4. Negative 3/4 square root of 1 plus 4. Negative 3/4 times 1 plus 4. Negative 3/4 plus 4. And you guys, that's going to give you 3 1/4 or 3.25 or 13/4. So any of that would work, you guys, but 13/4, you guys, around 3.25. So 2, comma 3.25, which kind of is right there. Alright, last one. What value of x would give you a 4? That would be 5. So if x is equal to 5, we get negative 3/4 square root of 5 minus 1 plus 4. Negative 3/4 square root of 4 plus 4. Negative 3/4 times 2 plus 4. 2 times negative 3, you guys, is negative 6. Negative 6 over 4 is negative 3/2 plus 4. And when you guys add that, that's essentially 5/2 or 5.5. Oh, sorry, not 5.5, 2.5. So this is around 2.5, which is really 5/2. So 5/2 or 2.5, you guys. 5, comma 2.5, which is right there. So that's what your graph should look like. Now, if you were to test this with transformations, right? That's up 4. That's right 1. This is a vertical shrink. And this is reflect across x-axis. So if this was your guys' parent, right? Right 1, up 4. You reflect it across the x-axis, which means it would have done this. And then since it's shrunk, then that means it's under that curve. So that would have matched up pretty good. Again, transformations, you guys, just further emphasize that, you know, you did your graph correctly. Alright, so that was that first page, if you guys need that help. Now here's your guys' part 2. Alright, describing your guys' transformations. So I'll color coordinate for this, you guys. That is kind of thick. So this, you guys, plus 3, that means up 3. This is where you guys use your notes, right? Plus 4, that would give you guys left 4. There's 1. Alright, this one, that, you guys, is right 1. And this one right here, you guys, that is down 8. Remember, inside the square root is the opposite, right? Inside the square root is the opposite. So since it says x minus 1, that's why it was right 1. Alright, over here. Plus 5, that's up 5. Minus 3, that would give you guys to the right 3. This 2 is a vertical stretch by 2. And this negative sign, you guys, that is a reflect across x-axis. Number 4. So negative 9, you guys, that is down 9. And then this negative sign out here, you guys, is a reflect across x-axis. Alright, number 5. This right here, you guys, plus 5. Remember, if it's inside the square root, it's the reverse. So it's not right 5, but it's left 5. This right there, you guys. Since that your a value is greater than 1, that means you got a vertical stretch by 3. And this last one, you guys, number 6. Negative sign, reflect across x-axis. If there's a negative sign on the inside, you guys, it's reflect across y-axis. Alright, purple. This minus 8, you guys, that is to the right 8. And lastly, this plus 1, you guys, that is a up 1. So again, use your guys' notes to your guys' advantage for this. Okay, now we got these graphs. Graph the following and then state the domain and range. Alright, so... Okay, so remember we're trying to get these. So if I make my XY table... So in order to get 0, we need it to be negative 1. So negative 1 plus 1, you guys, is 0. Square root of 0, 0. 0 minus 2, negative 2. Now for the square root right here to be a 1, we should plug in 0 in for x. So 0 plus 1 is 1. Square root of 1, 1. 1 minus 2, negative 1. To get this to be a 4, well, we would just have to substitute in 3. So 3 plus 1, you guys, is 4. Square root of 4 is 2. 2 minus 2, 0. There's your guys' graph. Domain. How far left this graph goes? Negative 1. How far right? Infinity. How low it goes? Negative 2 to infinity. Okay. This next one, make an XY table. So in order for it to be a 0, x would have to in order for the square root to be a 0 on the inside, we should substitute in 2 in for x. So if you substitute 2 into x, 2 minus 2 would be 0. Square root of 0, 0. 0 times negative 1, 0. 0 minus 3, negative 3. Now, how do we get 1? Well, if we substitute 3 into x, we would get 1 on the inside of the square root. So plug 3 into there. 3 minus 2 would be 1. Square root of 1, 1. Negative 1 times 1, negative 1. Negative 1 minus 3, negative 4. 3 comma negative 4. And then lastly, how would you get this to be a 4? Well, if you plugged in 6 into x, you would get 4. So substitute 6 in for x. 6 minus 2, 4. Square root of 4, 2, which is negative 2, right? Negative 1 on the outside times the 2. Negative 2. Negative 2 minus 3, negative 5. So 6, 1, 2, 3, 4, 5, 6, negative 5. 1, 2, 3, 4, 5. There's your guys' graph. So how low does this, or sorry, domain is how far left to how far right. How far left, it goes to 2. How far right, it goes to infinity. How low does this graph go? Negative infinity, it goes all the way down. And then how high does it reach? Negative 3. 9. So remember, we try to get a square root of 0 on the inside, so we should probably plug in 3 into here. 3 minus 3, 0. Square root of 0, 0. 0 times 4, 0. 0 plus 2, 2. Okay, now we want to get this to be a square root of 1. So if we plug in 4, that would be a square root of 1. So if we plug in 4, 4 minus 3, 1. Square root of 1, 1. 1 times 4, 4. 4 plus 2, 6. 4, comma, 1, 2, 3, 4, 5, 6. And lastly, to get this to be a 4, right? We want that inside to be a 4. You would have to substitute in 7. So 7 minus 3, 4. Square root of 4, 2. 2 times 4, 8. 8 plus 2, 10. 1, 2, 3, 4, 5, 6, 7, 10 is going to be somewhere up here, you guys. So that's what your graph should look like. Okay, domain, how far left does it go? 3 to infinity. To how far right? How far down does it go? 2. How high up? Infinity. 10, xy table. Well, to get a square root of 0, x just has to be 0. So square root of 0, 0. 0 times negative 2, 0. 0 plus 4, 4. Next, if x was 1, that would give us square root of 1. So square root of 1, 1. 1 times negative 2, negative 2. Negative 2 plus 4, 2. Lastly, number 4, no. This has to be a 4, so substitute in 4 for x. So square root of 4, 2. 2 times negative 2, negative 4. Negative 4 plus 4, 0. And this is what your graph would have looked like. Domain, how far left does it go? 0 to how far right? Infinity. Range, how low does it go? It goes low negative infinity to how high? It goes up to 4. So hopefully this helps you guys out with tonight's homework, and I'm assuming we're going to have many questions tomorrow, which is okay because we're going to go through it and see how we can do. Alright, good job you guys. Peace.